Supercooling!
At standard pressure, water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. However, water doesn't always freeze when it's supposed to. When the conditions are right, you can put a bottle of water in the freezer for hours and it won't turn into ice until you make it. Liquids are subject to a state called supercooling. Supercooling is when a liquid is below its freezing point but does not solidify. Liquids don't suddenly become a solid at a certain temperature. There's a process involved. It has to do with how the molecules line up. Energy, caused by heat, determines the state of a compound. In a liquid, the molecules don't have as much energy, so instead of flying around in every which way like they would in a warmer state, such as a gas, they are moving slow enough for the bonds to be created between them, keeping them closely together but loosely ordered. At lower temperatures, where the molecules have the least amount of energy, they form a solid. The molecules are still vibrating, but since the bonds between them are so strong, they keep the molecules in place.
Now let's talk about the water in the bottle. To freeze, the water needs two things. One, it has to have low energy, therefore must be cooled. And two, it needs to form the intermolecular bonds that will keep it solid. For the second part to happen, the water has to first form a nucleus, the center point of which will be solid ice. This is a substance's nucleation site. It is where the water molecules slot together in just the right way to form the structure of the ice crystal. This allows other water molecules around it to form bonds, spreading out, eventually forming ice. However, nucleation sites don't happen by themselves. Something needs to cause them. Often impurities in water act as a nucleation site. A tiny molecule of something could be enough to give the molecule formation a nudge, so they rearrange themselves into a solid. Or the nucleation site can be formed if the water is physically disturbed somehow, like being shaken up a little.
So if you want to supercool your water, you must keep both of those things from happening. All you need is a freezer, a stopwatch, and a standard drugstore brand purified water. Do not use mineralized water as it contains impurities that can act as nucleation sites. Put your unopened bottles of water in the freezer for 2.5 hours. This should be enough time to allow the water to reach supercooling. During the 2.5 hours, do not open the freezer. The drop in temperature must be gradual, and if you open the freezer, it might cause enough of a disturbance to create a nucleation site. If everything goes well, after 2.5 hours, you should have some supercooled liquid water. Supercooled liquids are highly unstable. When they are below their freezing point, their molecules really want to form a solid. The laws of physics are commanding them to, but they just can't comply. And that is why with a small provocation, those supercooled molecules will snap into place. By hitting a bottle of supercooled water against the surface, you provide a nucleation site and will be able to see the ice crystals form almost instantly.